Hello everyone. In this video, I'm going to discuss the reverse linked list question of LeetCode. This question is present in the first question out of 6 questions mentioned in the LeetCode 75 curated list. And yeah, let's jump right into it. Jump right into this. Yeah, so I follow these 8 steps for each question to come to a efficient solution in each my video. So yeah, you can go through these, but yeah, I'll start with the first step, which is reading and understand the question. So yeah, let's start. The question says, given the head of a singly linked list, reverse the list and return the reverse list. All right. So the question statement is pretty simple. They say that they'll give us a list. Actually, let me use that. They give us a list and we have to return a list in the opposite direction. So if you see input is a pointer which is pointing to the head of the list. Output that they want is also a pointer, and this pointer will point at the back of the list. Or you can say, yeah, whatever you want to say. But back of the list, what I mean is like they give us this pointer and as an input, we want to return this pointer, which is basically, let's say if it's P1, P2, and if they give P1 as an input, we will need to return P2. But P2 should eventually lead to the remaining of the linked list. So yeah. So yeah, those are the inputs and outputs. And let's move on to write multiple test and edge cases. So the possible edge cases here is either the list is empty or the list has only one element. It can be anything of an integer, or it has more than one element. So in this case, what we're gonna do is we just return head because there's nothing in the list. If we return this, like if there's one, then yeah, we also can just return head because we say we don't need to reverse the list because there's only one item. So head points to tail and head itself. And then if it's this, then anything more than one, then we need to do some computation. So there are two ways. What I would say, let's go for brute force one, discuss first. Brute force idea that we can just think about is like, let's say linked list is 1, 2, 3, 4, 5. This is connected this way. Now, in the linked list is not like an array that you can just access any item at any time. It's more of a one pointer leading to another, to another, to another. So basically, if we want to confirm what's this elements in the linked list exist, then we have to iterate through the list once. So the brute force solution, it comes down is like iterate through this list, store this in vector, store the values. And now that we know that now we can access any of these values, then iterate the list again and start changing the values from the vectors. Start picking your vectors back. So when your list will start, like first step is iterate through list and create this vector. Second step is iterate through list this again and start picking up from the back of the vector and fill value. This so 5 will go here, then we go here, 3 will go here, 2 will go here, 1 will go here, and just return the head in the end. Now, if you think about it, we are iterating this list twice, so big of 2n. Like first is this, first is this. This is the time complexity, which will be big of n. But we are also using a vector, so space complexity will also be n. So that's a brute force where you can take an extra space, but still do it in big of n, just run 2 loops through the linked list. Now, efficient way that I like to do, just using the pointers in C++, by the power of pointers, is this. What you can do is this solution will be big of n and not like big of 2n. This will be big of 1n. Basically, we need to iterate through it only once. And space complexity will be big of 1. We are not taking anything. So this is much better solution just by manipulating pointers. So yeah, let's take an example and think about it. 1, 2, 3, 4, 5. Now we'll take 3 pointers. Let's say F for front, mid for middle, and actually let's just do L1, L2, L3. This is the front, this is mid, and this is end. So that's the pointer we are taking. So we'll start the iterating through the list when say with the like L2. Actually, let me do this. This list looks like this right now. So we'll start by saying L2, L3 points here, L1 points at null. Then we'll run a while loop, and like while we trade through this list, what in each while loop, what we're gonna do is first we are gonna push L3. Let me do actually. First we're gonna push L3 here. Then we're gonna change actually the pointer pointing L1, L2's next point. Now, so here's the assumption in this question, not the assumption, the logic behind it. For every loop and iteration, we want to have 3 pointers, 1, 2, and 3. So once you have 3 pointers, you can just return the middle pointers next from this. You can just change this. We still have these next pointers. So and then we can move our this here and this L3 here and just start continuing like that. So yeah, you'll get more once I start doing it. So yeah, first we move L3 to L2's next. Then now we know what L2's next is, which is L3. So we can just change L2's next to L1, which is the previous one, which is in case this null. So L2 points here, which is null. And then what we're going to do is next step is that once this is done, we'll say L1 also points here. L1 also points here once this thing is changed. And then we move L2 to the next part. So if you see, this is how exactly we started. L1 in the back and L2 and L3 here. But every time we run through this loop, it will change. Now again, let's start the loop and L3 this time because L2 is already pointing here. L3 will point here. Once this is done, we know where it's L3, L2, and L1 lies. What we're going to do is change where L2 is pointing, which is, we'll change this. And then once this is done, we'll make sure L1 goes to L2 place and L2 goes to L3 place. And then we're going to start again, which is L2 and L3 points here. So we'll do L3 here, L1 here. We'll break this and then make sure this works. And then this will come here, this will go here. Now L1 points here, L2, L3 point. Actually, L2, L3 points here, L1 points here. Basically, the core logic that let me like write the code here quickly to show you guys what I mean. So this will be the load logic. While L1, sorry, L2 is not is equals to null. What we're gonna do is first we're gonna say L3 is equals to L2's next. Then we're gonna say L2's next is equals to L1. Then we're gonna say L1 equals to L2, and L L2 is equals to L3. Now there's one edge case. Let's talk about this is the code. Let's there's one edge case. Let's say we are at 3, 4, 5. 3, 4, 5. Let's say L2 and L3 point here, L1 point here. So when we run this loop, L3 will become L2's next. So L3 will point to null. Now L2's next will become L1. That means this thing will change to this thing. Okay. Now L1 equals to L2. So L1 will point here. L1 points here, L2 points here, L2 points here. Now, if you do L2 is equals to L3, this will point, both L2 and L3 will point at null, and this loop will be gone out. But what we want to do is, whenever we see that this next is null, then we just want to return this node's pointer. Reason being, in the list in the back, we already reversed the pointers. But if we just keep going, then we don't have a track of this last pointer. So what we have to do is add a small condition here and say if L3 is equals to null, then just return L2. Basically, if you see L3 in this situation is always L2's next. So let me write the code again to, not the code, just an example again. So let's say this is the case where 1, 2, 3, 4, 5, this is reversed. Yeah, exactly like this. L1 points here, L2, L3 points here. This code will come and we say, okay, L3, put L3 as L2's next, which is null. So L3 points here, and then L2's next equals to L1. So this is next becomes this, and then L1 equals to L2. So L1 points here, and then if L3 is equals to null, return L2. So you see L3 is pointing to null. That this condition tells us that we are at the last node, so we'll just return L2, which is pointing here. And if you see L2's next is this, is this, is this, is this, is this. So the list is reversed. So yeah, that's the code. Big of n is the time complexity, big of 1 is the space complexity. And yeah, let's write this code to explain you guys. Let's write this code. So what are you gonna say? Let's say pointer L1, it starts from null because nothing is behind the head right now. And then we'll say L2, we'll say L3, and this will point at head. This will also point at head. And we can just start iterating through while L2 is not equals to null. And what we're going to do is first we will say L3 becomes L2's next, and then we'll say L2's next becomes L1, then L1 becomes L2, and we're going to quickly check if L3 is equals to null, return L2. If that's not the case, then L2 will becomes L3. And then at the end, we return null. So if you think about it, if an empty node is sent to us, we'll run this code, but this loop will never be run because L2 is not equals to null. So we're going to return null, which makes sense. If head is only pointing to 1, we'll go through this code. Both L2, L3 will point to head. L3 will start pointing to a null because the list only had one value, and then this code will run, and then we'll return L2, and L2's next will point to L1, which is null, and if it's the list only contains one node, then it was originally the case too. So yeah, let's run this again. L3 goes to front of L2. L2's next goes to the back of L2. L1, the back of L2 becomes L2, and then if L3 is equals to null, we return L2. Like, I mean, the next one is null, then we return the current one, and then, yeah, if not, then this happens. So, yeah, let's quickly run this code. Return null. Oh, my bad. Yeah, so this looks good. Let's submit. 3 millisecond beats 86%, and 62 looks good to me. Yeah, this is a bit tricky approach. I would suggest uh, try creating your own list and moving pointers. But once you get hold on how to analyze pointers and change them and without taking any space, this is a very efficient way and very clean way, to be honest. But yeah, thank you everyone. Let me know if you have any questions and comments. Thank you.